Here we are on the second to last question of Stats and Mechanics Year 1, Chapter 9, Question 17. A train starts from rest at station A and accelerates uniformly at 3x meters a second minus 2 until it reaches a velocity of 30 meters a second. So it starts at, let's do a velocity time graph just to see. So it starts at rest and it accelerates with 3x meters a second minus 2 until it gets to 30 meters a second. Okay. For the next t seconds, the train maintains this constant velocity. So between here and here, t equals t. Fine. The train then deaccelerates uniformly at x meters a second. So it comes across here and then it comes down here at x meters a second minus 2. Okay, until it comes to rest at station B. The distance between the stations is 6 kilometers. So this is station B. Did it start at station A? Yeah. And the entire thing is 6 kilometers. Lovely. And the time taken from A to B is 5 minutes, which straight away I'm going to put in as 300 seconds to keep it with SI units. And in the same way, this whole distance should be 6,000 meters. Right, sketch a velocity time graph to illustrate this journey. Yeah, just did that. I wonder, can we work out the times on it, or is that something that's going to be at the end? Okay, so if we do 30 meters a second up there for t, that'd be 30t. Don't think we can. Right, was that everything with that one? I think so. Now then, yeah, velocity time. Okay, that was an easy win for part A. Part B then. Part B. Show that 40 over x plus t is equal to 300. Where has that come from? I suppose we could look at something that does distance. We know the length of that is t. We know the length of that is 600 or 300. Yes. So the total distance is equal to 6,000. And that's got to equal the half a plus b times h, the trapezium formula, where a and b are the bottom and the top of the trapezium, and the h, of course, is the height. So that means we can put it into here and we can say that 6,000 is equal to a half times t is the length of the bit on the top plus the 300 for the total distance at the bottom, the 300 seconds, and the height is 30 meters a second. Okay, and now we just got to rearrange that all around until we get something that looks a bit more like what we've got up there. 40 over x. How come they have an x in theirs? So let's have another thought about this, because I've created something here that doesn't have an x in it. So it's equal to 300. What is 300? The total time. So what could we do to work out the total time? So we know we've got a time in here, and we know we've got an acceleration in here because x is to do with the acceleration of the 3x and the minus x on the different suvats in there. Okay, and so we could look at possibly, I don't know, average speed or something might be what it is, but really it feels like it's a bit of final velocity being 30, initial velocity, acceleration and time. It feels like it's a combination of all of them here to try and pin down what these T1s and T2s might be, sort of thing. We know this one, call it T3 for the sake of it, is equal to T, and so all of them add up to 30, so presumably this is all of the times added up, where we do know the velocity. So if we have a quick look at this section in here, we look at this section of the graph here and we do a suvat on that, okay, we are going to have, let's just write out suvat, okay. The time we don't know, the acceleration was 3x, the final velocity was 30, the initial was 0, and the distance we don't know. So if we take something without s in it, which would be v equals u plus at, okay, and if we use that and we say 30 is equal to 0 plus 3xt, and then this is the t1, okay, and so if I take 30 and I divide it by 3x, I will have t1. If I do the same up here for this section, okay, and if I make suvat for the second half of that, okay, again I don't know my distance, my initial was 30, my final was 0, my acceleration was minus x, okay, and then my time I'm calling t2, and again if I use this same one, 0 equals initial 30 plus minus xt, I will end up with 30 over x is equal to t2, and if I take all of these things, okay, t1, t2 and the main t here, they all equal 300, which is what it's equal to. So I can say that t plus 30 over 3x plus 30 over x is equal to 300. Now I've got something with x's and t's in it, so hopefully it's going to give me the same thing. So let's put all of that together, okay, making this one into a 3x on the bottom, which makes this one into a 90. Adding those two together gives me 90, 100 and, could have just made it 10 and 30, couldn't I, anyway, 9, 10, 11, 12, so t equals 120 over 3x equals 300. That should be a plus, not an equals. And so with the cancelling on that, okay, we end up with 40 over x, doing the cancelling there, plus t equals 300. So it's spotting not for the distance at the bottom of 6,000, but the total time of 300 seconds to put it together. All right. Part C. Part C. Find the value of t and the value of x. Well, we've already got something up here in the orange that should be able to give me the value of t. Okay. So 6,000 equals a half t plus 300. Let's just take all of that. And start putting it together. So where's that going to be? 15. 6,000 divided by 15 is equal to t plus 300. 6,000 divided by 15 is 400. 400 minus 300, 100 equals t. So there's that bit done, and then we can use the equation from the top here. Okay, this is going a bit loopy, and we can start putting it in, and we can say 40 over x plus t, which I have just said is 100. So that t equals 300. So what's that give me? 40 over x equals 200. 40 over 200 gives me x. Okay, which is 1 over 5. Right. Part D. Calculate the distance the train travels at a constant velocity. Well, if it does 100, we just worked out that big T is 100 and it was doing 30. So D must be, was it doing 30? Yes, 30 times 100, which is 3,000 meters. Okay, straightforward, really. They gave us 2 marks for that. That was very kind of them. And now finally E, calculate the time taken from leaving A until reaching the point halfway between the stations. Now, the point halfway between the stations is going to be 3,000 meters. So what we really need to know is the distance that we've got for the green section here. We need to know this distance. Then we know the distance that we've got to travel in here, which will allow us to find the other t at this 30. Okay, so first things first, let's use the green suvat to find distance. So we'll use the one which doesn't have time in it. Okay, which is v squared equals u squared plus 2as. So let's just take that entire suvat statement there and bring it to our working area. Okay, and we've just said that we're going to use v squared equals u squared plus 2as. So 30 squared equals 0 squared plus 2 times 3x. What was x? It was a fifth. 3 times a fifth s. Okay, so 900 being divided by, so 3 times a fifth, funny enough, is 3/5 times by 2 gives you 6/5, and 900 divided by 6/5 750. meters, which equals S. So we have got 700 meters. We've got 750 meters up until this point, which means we are now looking for 3,000. Take away the 750, which is 2,250. 2,250, and that will be 2,250 divided by 30, which will be 75 seconds. So this bit here is 75 seconds in between here and here. Did we ever work out what T1 was? We did. We had it here. So we have 30 divided by 3/5. Okay, and so 30 divided by 3/5 is 50. So that bit there is 50 seconds. So of course 75 and 50. So 75 plus 50 gives you 125 seconds. Is that what I was looking for? Yes. All right. Now do.